Let's take a look at improving the clock that's triggering our event table. We have replaced the lamp with a numeric readout. The numeric readout is set in the same way as the lamp. It is always active. You can find the numeric readout by right-clicking in the structure, selecting Built-in Module, Panel, then Numeric Readout. Let's take a look at what happens when we start and stop the clock by looking at the numeric readout in the panel view. When we hit play, the event table works as expected. However, when we hit stop, the event table returns to the start and reads off the first value. If this event table was triggering a drum sample, we would hear the sample when hitting stop. The first hit would also be missed when we restarted the clock. When we stop the clock, the song position module sends out a 0. This is sent through the structure, causing the problem. Let's solve this problem. Right-click, select Built-in Modules, select MIDI in, and select Start-Stop. The G output from the Start-Stop module sends out a 1 when the clock starts and a 0 when it is stopped. The RST output sends out a 1 after the clock has been reset and started again. Right-click, select Built-in Modules, select Event Processing, and select Separator. We are going to need 2 of these modules, so let's duplicate it. Right-click on the separator and select Duplicate. The separator takes events at the input and sends them to one of its 2 outputs, either high or low. The threshold input will determine where the event is going to be sent. For example, if the threshold is set at a value of 1, any events with a value higher than 1 will be sent out of the high output, whilst events below 1 will be sent out the low output. The threshold is set to 0 should no wires be attached. Let's wire up the 2 separators. We are going to wire the RST output of the Start-Stop module into the input of one separator. Delete the current wire leaving the song position module by right-clicking on the wire and selecting Delete Wire. Wire the song position output into the input of the other separator. We are now blocking the 0 that is admitted from both these modules when the master clock is reset. Right-click, select Built-in Modules, select Event Processing, and select Value. This module takes the value from the lower input, audio, and sends it out when the trig input receives an event. The value module holds its last received value to be triggered. A 0 will be sent from the low input of the separator when the clock is reset. A 0 is therefore always being stored in the value module. Let's wire the high output from the upper separator into the trig input of the value module. Right-click, select Built-in Modules, select Event Processing, and select Merge. This module is used to merge event signals. Wire the output from the value module into the merge module. Wire the high output from the lower separator into the merge module also. You can hold down Control to create a new port whilst dragging the wire to the merge module, or change the number of ports in the module's properties. Finally, wire our new chain into the A input of the modulo module. Make sure all our new modules are monophonic. We are now using the Start-Stop module to release the 0 being stored by the value module. Now when we hit stop, Both the song position module and the start-stop module will release zeros. Both zeros are killed off by their adjacent separators. When play is hit, the start-stop module sends out a 1. The separator releases this 1 via the high output. This triggers a 0 stored by the value module. Let's see if we have solved the reset problem by taking a look at the panel view. When we hit play, a 1 appears in the numeric readout with respect to the event data drawn on the table. When we hit stop, a 1 is no longer admitted.